Well, as you see, it's critically important to impact our world in transportation. But another critical world, of course, is our health and our health care. Now, we do the best that we can to prevent disease and illness. But sometimes when we can't do that, treatment, of course, is our first response. Beyond that, though, our focus turns to recovery and rehabilitation. Now, there's been amazing breakthrough work done in the area of rehabilitation. Let's hear a little bit more about that. We'll hear from a group that is the winner, the Student Design Competition, also a winner in previous Engineering Impact Awards, and they're really doing great work to move us forward in this area. Let's hear from a group that comes all the way from the University of Leeds in the UK. Ladies and gentlemen, welcome to the stage the team from Project Alan. Gentlemen, welcome. Professor Leavesley, it is awesome to have you here again. Now, we know rehabilitation is important. Give us a sense of why that's so and what we get from rehabilitation that we just can't get in any other way.
Okay, so rehabilitation is about getting back normality. It's about getting back sort of independence. If we look at rehabilitation from our perspective, it's about relearning how to move after people have suffered stroke. So it's about retraining your brain. It's about rewiring, reprogramming your brain. And that's something that you just can't get from any medicines. Now, stroke is a big problem. In fact, stroke is the biggest cause of severe chronic adult disability. Now, across the world, every year, 15 million people are going to suffer a stroke. Those people that survive that stroke, 85% of those will suffer from some sort of arm paralysis. And despite our best efforts, 5 years later, a quarter of those will still suffer problems moving their arm. So it's a big problem. But what makes it worse then is these people need long-term intensive physiotherapy. And trying to train and deploy enough physiotherapists to satisfy this need would place huge burdens, huge financial burdens on our healthcare services. So we challenged our students to come up with some new ways of delivering the extra additional therapy that people need.
So time in therapy is critically important, and you just can't get it. With it, you can make much greater progress. This is something that Project Alan is moving forward. Can you tell us about that?
So for us, it's all about getting patients to relearn how to use their arm independently at a time and place that suits them. For the past year, Project Alan has been working on a commercially viable rehabilitation device for use in the homes of stroke survivors. The idea is to use robotics together with conventional therapy to increase the chances of them making a full recovery. So far, we've had great progress in two main areas. Firstly is the MyPalm rehabilitation device itself, and secondly is an Alan arm robotic testing solution for rehabilitation devices such as the MyPalm.
Yeah, our rehabilitation device, the MyPalm, works in the same way that a therapist does by providing assistance to the patient as they move their arm in exercise tasks. The assistance level provided by the robot changes over time automatically, so it reduces as the patient recovers. Dave, would you like to have a go on the device?
I'd love to have a go. Let's have a go.
All you have to do is grab the handle and eat all the apples. How hard can it be?
How hard can it be?
So you can even try without looking, just using the haptic feedback.
Use the force.
So all the software is done in LabVIEW, including the database access and the robotic control running on a single board Rio. The single board Rio and its built-in FPGA means we can do tens of thousands of calculations every second, giving us smooth, safe, and reliable control.
We used to do all of our testing of MyPalm using people, just like Dave is doing for us now. But that wasn't repeatable enough and not very efficient, no offense, Dave. So we built an Alan arm to test our robot more thoroughly.
So you're using the NI platform, our Rio technologies. You're doing thousands of calculations per second, Jacobians if I'm not mistaken, tens of thousands per second, millimeter accuracy. This thing's incredible. But now we have an assistive robot over here, and you're using our platform for that as well. Can you tell us about the Alan arm?
As you can see on stage, Alan arm has been through a couple of iterations, starting from a modified open-source 3D printed robot powered by MyRio, to this, a stronger, faster, more precise, and much more reliable device powered by compact Rio.
So Dave, do you fancy seeing how you stack up against Alan? Man versus machine. You want to give it a go?
Let's give it a go. Here we go.
First person to eat 20 apples, let's see. Are you ready?
I am ready.
Okay. On your marks, get set, let's go. And remember, we're looking at not just speed, it's accuracy and smoothness. We've got Alan over here then, already up to 7 or 8. Dave, how are you doing? 6, 7 over there. That's pretty good going. What are you up to? 15, 16 over there. It's pretty good. Oh, I'm afraid, Dave, Alan's just pipped you to the post. You used the force, but perhaps not enough.
Well, fellas, that's incredible. You can feel it helping you. It's amazing. In my defense, however, guys, that really wasn't an apples-to-apples comparison, I would say. But this is great work. We're doing amazing things here with this. You can really sense how this will work you and give you that time and therapy that you need. I can imagine this would make a huge impact on people's progress. Can you give us a sense of that impact?
Absolutely. Using these sort of devices for durability testing and rehabilitation robot validation helped us to reduce development time and product time to market. And really, at the end of the day, what this means is that patients, people who needed this help the most, can get it much quicker than ever before. Using devices such as this one, patients can get unlimited, personally tailored, and independent exercise routines. And that means that they can recover much quicker and fully regain their independence back.
So unlimited time in therapy, that's incredible, incredible work. Guys, this can have a huge impact on people. Can you tell us what you learned by doing such an important project?
We realized the importance of working with the engineering community to accelerate research. The open source and maker movement has been key to our success, as it helped reduce the time required for the mechanical build. Furthermore, we wouldn't be able to overcome the technical challenges and time limitations without the seamless transition between the Myrio and Serial platforms. This helped reuse existing code and knowledge of the NI platform approach to focus on the actual challenge of helping people in need.
Well, guys, congratulations on winning the Student Design Competition, also the Engineering Impact Award. Such impactful work. We want to thank you for bringing this, and thank you for sharing it with us today.
Thank you, Dave.